All right, another type of reaction is called a polar reaction, and these are going to be the most common. And again, we're just introducing these topics. We'll spend a lot of time on all of these topics in great detail. So in a polar reaction, you have a reaction with either charges or partial charges. So there's usually a reaction between a partial positive and a partial negatively charged atom, right? And think about chemistry, one of the big things is that opposites attract. So there'll be an attraction here, and then eventually a reaction. And so one of the big things of organic chemistry is being able to spot these positive and negative charges. Most chemical or most reactions to organic chemistry is between the partial positive and the partial negative. So for example, if we have this carbon right here, we can see that we have a chlorine up here and then a carbon. If we think about our electronegativities, this chlorine is going to be more electronegative, and so it's going to make this carbon partially positive. Another example can be over here, carbon bonded to this lithium. You could also draw this as kind of an ionic setting, but in this case, we'll draw a covalent bond. But either way, we know that lithium is much less electronegative than carbon, and so this carbon is partially negative. Right, so we can see we have a partially positive and a partially negative carbon. And so these are so important that they get special names. The partially positive carbon is called the electrophile. Or we say that this carbon is electrophilic. Right, phile or philic means loving, and so the electrons is negative charge, and so this is negative loving, right? It's partially positive, so it likes negative. And then vice versa on this other side, we have this partially negative carbon. We call this a nucleophile. Or we say that this carbon is nucleophilic. If you think about the nucleus of an atom, it's positively charged, and so this means that it's positive loving, which makes sense because it's negative, right? Opposites attract. And so in organic chemistry, 9 times out of 10, the reaction is the nucleophile attacking the electrophile. Right, so nucleophiles attack electrophiles to form bonds. So for example, maybe you have some kind of CH3 with a negative charge and thus a lone pair, and then another CH3 with a positive charge. This is your electrophile, or this is your nucleophile. This is your electrophile. The nucleophile will attack the electrophile, and you will form a bond. Think about the charges on both of these when the reaction is complete. They will be neutral, and now there'll be a newly formed bond that came from the electrons of the nucleophile. So again, this is the nucleophile. This is the electrophile. And if you think about what you're doing, you're transferring an electron pair. So this is indeed a Lewis acid-base reaction. In organic chemistry, we don't call them Lewis acids and bases. We call them nucleophiles and electrophiles, but it's essentially the same idea. This nucleophile is a Lewis base, while the electrophile is the Lewis acid. Right, electron pair donor and electron pair acceptor. And so overall, we spend a lot of time on figuring out how we get from reactants to products. And so when you're thinking about the mechanisms, you want to think about 2 things. The first thing you want to think about is what happened. And so when you're thinking about what happens, there's kind of 2 things you want to think within that, and that's what bonds are broken and what bonds are formed. If you can answer these 2 things, you're on your first step to figuring out the mechanism. And then the second step is how did it occur? And this is where the arrow pushing comes in, right? So we're going to push arrows around to show how these reactions occur. But really the first step is to identify what's the change?